Hello. Today we are going to discuss about the problems on kinetic theory of an ideal gas. Very important for Neet, JEE means as well as Eamcet. See here the first question is given. The kinetic energy of translation of 20 gram of oxygen at 47 degrees Celsius is. Here molecular weight of oxygen is given. O2 is equal to 32 gram per mole and universal gas constant value 8.3 into 8.3 joule per mole Kelvin is given. Mole Kelvin is given. Of course, here average translational kinetic energy expression E is equal to 3 by 2 into N into RT. Average translational kinetic energy E is equal to 3 by 2 into nRT. But here we are provided with the mass of the gas. Here we are provided with mass of the gas as well as molecular weight. And here we are provided with the temperature T. To convert it into absolute scalar temperature, we have to add 273. Of course, that implies expression can be rewritten as average translational kinetic energy is equal to E into number of moles can be written as small m by capital M into RT. That is equal to 3 by 2 into mass of the gas is 20 grams. Mass of the gas is 20 grams. By molecular weight of oxygen is given, that is 32 into 8.3 into. What about the temperature? Here we have 47 degrees Celsius. Small t is equal to 47 degrees Celsius. That is absolute scale of temperature is equal to 47 plus 273. That is equal to 47 plus 273. That is the 320, of course. 320. 273, 47. 10, 320 Kelvin. That is 320 Kelvin. That can be written as 320. That is equal to 32 ones, 32 tens, 83 into 2 ones, 2 tens, 2 ones, 2 tens. So finally 83 into 30, 83 into 30, 0, 3 3 is 9, 3 8 is 24, 2490 joules. 2490 joules will be the answer. Now, here we have the second question. See here. Here we have second question, that is the average kinetic energy of a gas at minus 23 degrees Celsius and 75 centimeter pressure is 5 into 10 power minus 4 erg for hydrogen. The mean kinetic energy of O2 at 227 degrees Celsius and 150 centimeter pressure will be 150 centimeter pressure will be. See, the average kinetic energy of at minus 23 degrees Celsius. Here temperature is given. Temperature minus 23 is given. 75 centimeter pressure. 5 into 10 power minus 4 in for hydrogen. The mean kinetic energy of O2 at 320 or 227 degrees Celsius and 150 centimeter pressure will be. Basically, average translational kinetic energy E depends on absolute scale of temperature. At first, that depends on absolute scale of temperature. So that implies here we can written E2 by E1 is equal to T2 by T1. E2 by E1 is equal to T2 by T1. That is equal to minus 23 plus 273. The given Celsius value can be converted into absolute scale of temperature. That's why you have to add 273. And yes, here we are provided with the second temperature, that is T2. This is T1. So we have to write here 227 by 227 plus 273 as well as minus 23 plus 273. That is equal to, this one will be 250 and it can be 500. Okay, of course 500. 73 over 27, 300, 500. That is equal to 2. So finally E2 is equal to 2E1. Energy becomes doubled. Next, we have to find the average kinetic energy, of course. The mean kinetic energy of O2, mean kinetic energy of O2 at 227 degrees Celsius, and the pressure will be, of course, E2 is equal to, we can write 2E1. Okay, next. Here there is a value is given. Yes, 5 into 10 power minus 14 energy is given, you know. Yes, just wait. Here we have E1 is given there. See, 5 into 10 power minus 14 energy is given. For that, E2 is equal to 2 into 5 into 10 power minus 14, that is equal to 10 into 10 power minus 14 erg. 10 into 10 power minus 14 erg. That will be the answer. And also it can be given as, say, 10 power minus 13 also. Okay, 10 power minus 13 erg also. Okay, next question. Now, at what temperature is the kinetic energy of a gas molecule double that of its value? Of course, we know E is directly proportional to average translation kinetic energy. E is directly proportional to absolute scale of temperature. That implies here given E1 is equal to E, then E2 is equal to 2E. And at what temperature is the kinetic energy of a gas molecule double that of its value? Of course, we have to find the temperature. We have to find the absolute scale of temperature, of course. But in that question, we are provided with the value at 27 degrees Celsius. Double that of its value at 27 degrees Celsius. What temperature is the kinetic energy of gas molecule? Double that of its value of 27 degrees Celsius. So initial temperature T1 is equal to 27 degrees Celsius. That implies capital T1, absolute scale of temperature, we have to add 273 Kelvin. That's why initial temperature becomes 300 Kelvin. So by substituting in the expression, that is, if E is directly proportional to T means we can develop that it as E1 by E2 is equal to T1 by T2. That implies instead of E1 we have to write E by 2E. E by 2E is equal to initial temperature is 300 Kelvin. 300 Kelvin by T2. Now E gets cancelled. That implies 1 by 2 is equal to 300 by T2. Now T2 is equal to 300 into 2, that is equal to 600 Kelvin. T2 is equal to 600 Kelvin. If you want to convert it into Celsius scale, but if answer is given in Celsius means we have to subtract 273. Now T2 is equal to minus 273. We get or else 600 minus 273, no problem. That is equal to 600 minus 273, that is equal to 327 degrees Celsius. Okay, now here we have another question. The average thermal energy of a helium atom at the temperature of sun. Average thermal energy of a helium atom at the temperature of sun. Bracket low 6000 Kelvin is given. Sun temperature 6000 Kelvin is given. So that we know that expression E is equal to 3 by 2 into Boltzmann constant into absolute scale of temperature. Boltzmann constant into absolute scale of temperature. We have to choose this expression. Why? Because of in that options powers answer will be given in 10 power something, order of 10. Then we have to select this. Why? Because of Boltzmann constant value 1.38 into 10 to the power of minus 23. Boltzmann constant value 1.38 into 10 power minus 23. That's why. Take it. That is 3 by 2 into 1.38 into 10 to the power of minus 23 into absolute scale of temperature value 6000. Absolute scale of temperature value 6000. So that is the 2 ones to 0.6s and 2 nines, that is equal to here 3 into 69 into 10 power minus 2 into 10 power minus 23 into 6 into 10 cube. After solving this one, we will get the expression 1.24 into 10 power 19. 1.24 into 10 power 19 joules will be the answer. Okay, next. Now see here, the average thermal energy of nitrogen atom at the typical core temperature in case of a star, 10 power 7 Kelvin. Of course, average thermal kinetic energy as like in the previous question. Again we have to solve. That is nothing but E is equal to, provided with E is equal to 3 by 2 Boltzmann constant into T, that is equal to 3 by 2 into 1.38 into 10 power minus 23 into absolute scale of temperature value is given, that is 10 power 7. So here 2 into 3 by 2, 3 into 0.69 into 10 power minus 16. 10 power minus 16. Now 69 into 3, 10 power minus 16 into 0.69 into 3, 0.69 into 3, 3 nines 27, 3 sixes 18, 3 nines 20, 3 nines 27, 3 sixes 18, that is 20, 2.07, 2.07. So that is equal to 2.07 into 10 power minus 16 joules. That is the average thermal kinetic energy, 2.07. Okay, next question. Now here we have the fraction of molecule volume to the actual volume occupied by the oxygen gas at STP, standard temperature pressure. Take diameter of oxygen is equal to 3 angstroms. So here we have to write the formula for fraction of molecule volume. Fraction of molecular volume is equal to actual volume of the molecule, by molecular volume. Actual volume of the molecule can be written as 4 by 3 pi r cube. Why? Because of molecule will be looks like a spherical nature. That's why volume of the sphere V is equal to 4 by 3 pi r cube. According to alpha scattering experiment, we know R is equal to 1.5 into 10 to the power of minus 10 meter. That's nothing but 1.5 angstroms, of course. 1 angstrom is equal to 10 to the power of minus 10 meters. 1 angstrom is equal to minus 10 meters. Okay. Now here that is equal to actual volume of the molecules. 4 by 3 into pi into, instead of r cube we have to write 1.5 into 10 to the power of minus 10 whole cube by 22.4 liters. 22.4 liters. Actual molecular volume V is equal to 22.4 liters. That is equal to 22.4 into 10 to the power of minus 3 meter cube. Since 1 liter is equal to 1000 cc. 1 liter is equal to 1000 cc. That is equal to 10 cube into, instead of cc we have to write centimeter cube. We have to write 10 to the power of minus 2 meter whole cube. That is equal to 10 cube into 10 power minus 6 meter cube. That is equal to 10 to the power of minus 3 meter cube. That is equal to 10 to the power of minus 3 meter cube. Then by Avogadro number we have to write molecular volume. Molecular volume, nothing but say we have to write here what is the 22.4 into 10 to the power of minus 3 by Avogadro number 6.023. 6.023 into 10 to the power of 23. That is equal to 4 by 3 into 22 by 7 into 22 by 7 into 1.5. 1.5 into 1.5 into 1.5, 3 times. 1.5 into 1.5 into 1.5 into 10 to the power of minus 30 into, this is the value can be written in the numerator, 6.023 into 10 power 23, 10 power 23 by 22.4 into 10 to the power of minus 3. That is equal to, after simplifying this one, we get the answer 3.8 into 10 power minus 4. 3.8 into 10 to the power of minus 4 will be the answer. Okay, so this is the data we have to calculate volume. Okay, that is about the fraction 3.8 into 10 to the power of minus 4. 3.8 into 10 power minus 4. Okay, see clearly. Fraction of molecular volume is equal to ratio of actual volume of the molecule by molecular volume, and fraction is equal to, that is substituted using 4 by 3 pi r cube. According to the experimental verifications, size or shape of the molecule will be, looks like a spherical shape, sphere shape. Okay. So actually here we are provided with oxygen. Here we are provided with oxygen 3 angstroms. Okay, that's why I am writing here O2 diameter D is equal to 3 angstroms given. That is equal to 3 into 10 power minus 10. For that radius R is equal to D by 2. That is equal to 3 by 2 into 10 power minus 10. That is 1.5 into 10 power minus 10. That's why I am writing here R value is taken as say R is equal to 1.5 into 10 to the power of minus 10 meter. Now the molar volume occupied by 1 mole of any gas at STP is, the molar volume occupied by 1 mole of any gas or ideal gas at STP is, we know equation of state or ideal gas equation, PV is equal to nRT. PV is equal to nRT. The molar volume occupied by 1 mole of gas is given. That's why we have to take N is equal to 1 for 1 mole of gas. For 1 mole of gas. So pressure P is equal to 1.013 into 10 power 5 Pascal into volume V is equal to number of moles 1, R value 8.314 into, at STP absolute scale of temperature is 273. At STP condition absolute scale of temperature is 273. Now volume V is equal to 8.314 into 273 by 1.013 into 10 power 5. That can be written as, that is equal to 22,400. 2240 into 10 power minus 5. 2240 into 10 power minus 5. That is equal to 22.4 into 10 power minus 3 meter cube. That is equal to 22.4 liter. Since 1 liter is equal to 10 power minus 3 meter cube. 1 liter is equal to 10 power minus 3 meter cube. VRMS. At what temperature is the root mean square velocity of gaseous hydrogen molecules is equal to that of oxygen molecules at 47 degrees Celsius. At 47 degrees Celsius. RMS velocity VRMS is equal to root of 3 RT by M. That implies VRMS is directly proportional to root of T by M. Root of T by M. Here we are provided with two gases, hydrogen gas and oxygen gas. So V hydrogen, VRMS of hydrogen gas by VRMS of oxygen gas is equal to root of T hydrogen, temperature of hydrogen by molecular weight of hydrogen, of course T hydrogen by T oxygen into, as it is in inversely proportionality, as it is inverse proportionality, we have to write MO by MH, MO by MH. Now VH by VO is equal to root of TH. Temperature, we have to find temperature of hydrogen. Yes or no? At what temperature the root mean square velocity of gas is hydrogen. So we have to find the temperature of hydrogen. But oxygen temperature is given 47 degrees Celsius. So that is 47 plus 273 into molecular weight of oxygen 16 into 2. As it is diatomic, we have to write 16 into diatomic gas. That's why we have to write, multiply with 2 and 1 into 2. And we know that VH is given that VH is equal to VO. VH is equal to VO, the ratio of VH VO becomes 1. So 1 is equal to root of TH by 47 and 273. It may be 320, of course 320, okay, 320 into 32 by 2, 32 ones, 32 tens, squaring on both sides we get 1 square is equal to TH by 20, TH by 20, then TH is equal to 20 Kelvin, TH is equal to 20 Kelvin, TH is equal to 20 Kelvin will be the answer, okay, 20 Kelvin, okay, write down. A sample of gas at 0 degrees Celsius, to what temperature it must be raised in order to double the RMS speed of the molecule? A sample of gas at 0 degrees Celsius. That is, the temperature is given T1 is equal to 0 degrees Celsius. That implies the absolute scalar temperature T1 is equal to 0 plus 273. That is equal to 273 Kelvin. 273 Kelvin. At what temperature it must be raised in order to double the RMS speed? So T2 is equal to question mark. We have to find T2. So to what temperature must be raised in order to double the RMS speed? Let us consider V1 is equal to V, V2 is equal to 2V. V1 is equal to V and V2 is equal to 2V. Now we know the relation is nothing but say V is directly proportional to root T, as the given a sample of gas, single gas is given. That's why molecular weight will be constant. So that V is proportional to root T. That implies V1 by V2 is equal to root of T1 by T2. That implies V by 2V is equal to root of T1, 273 by T2. 1 by 2 is equal to root of 273 by T2. Squaring on both sides we get T2. Squaring on both sides we get 1 by 4 is equal to 273 by T2. That implies T2 is equal to 273 to 4. 4 3s 12. 4 7s 28. 4 2s 8. 1092 Kelvin. That implies T2 is equal to 1092 minus 273. That is equal to 890 degrees Celsius. 890 degrees Celsius. At what temperature will the oxygen molecules have the same RMS speed as hydrogen molecules at 200 Kelvin? At what temperature will the oxygen? Here we are provided with different gases. So molecular weight will be there, and and we have to find the change in temperatures, but given same RMS speed. V is equal to root of 3 RT by M. Here V is constant, R is constant, 3 is constant. That implies T by M is equal to constant. That implies T is proportional to, okay? That is T is proportional to molecular weight. That implies given the gases are T oxygen by T hydrogen is equal to M oxygen by M hydrogen. M oxygen by M hydrogen. We have to find the temperature of oxygen. TO we have to find. Now that implies TO is equal to MO by MH into 2H. MO molecular weight of oxygen 16 into 2 as it is diatomic by 16 into 1 into 2 hydrogen also diatomic into temperature given 200 Kelvin 2 ones 2 hundreds, that is equal to 3200 Kelvin. 3200 Kelvin is the answer. In that option also there is no conversion, so that's why we have to see here. RMS velocity of a particle is V at a pressure P. If pressure is increased to 2 times, then RMS velocity becomes. Here pressure is increased to 2 times. But VRMS depends on absolute scale of temperature, independent of pressure. So no change in speed as pressure is increased or decreased. There is no effect of pressure. On RMS velocity. Now here see another question. The respective speeds of molecules are 1, 2, 3, 4, 5 km per second. The ratio of their RMS velocity and average velocity will be. So here we are provided with the speeds of some molecules of gases. That is, we have to find first RMS velocity. The expression or the equation for VRMS is equal to root of formula is V1 square plus root of V1 square plus V2 square plus V3 square plus V4 square plus V5 square by 5. That is equal to root of 1 square plus 2 square plus 3 square plus 4 square plus 5 square by 5. That equal to root of 1 plus 4 plus 9 plus 16 plus 25 by 5. See here 25, 50, 55 by 5. That is equal to 55. See here. That is equal to 55 by 5. That is equal to root 11. That is VRMS. What about V average? V average is equal to V1 plus V2 plus V3 plus V4 plus V5. Sum of the quantities by total number of quantities. That equal to 1 plus 2 plus 3 plus 4 plus 5 by 5. That is equal to 3, 3, 6, 6, 4, 10, 10 5, 15. 15 by 5, that is equal to 3 km per second, root 11 km per second. Now, VRMS by V average is equal to root 11 by 3. Root 11 by 3 will be the expression. The ratio VRMS is to answer. VRMS is to V average is equal to root of 11 is to 3.